Hello, the topic of this screencast is the quantum mechanics model. Unlike Bohr's model of the atom, the quantum mechanics model applies to all elements. There are 6 big ideas in the quantum mechanics model. Big idea number 1. There is no such thing as an electron path or orbit. Electrons are not in fact particles. Rather, they are clouds of negative charge. Therefore, we can only show the electron's most probable location in the atom, not its exact position. The propeller blade on this airplane has the same probability of being anywhere in the blurry region, but you can't tell its location at any instant. The electron cloud of an atom can be compared to a spinning airplane propeller. Note that an electron, like a propeller blade, has a very low probability of being found outside its orbital, but a very high probability of being found inside it. In addition, orbitals have varying degrees of shading, indicating the relative probability of finding electrons inside the orbital itself. The darker the shading, the higher the probability of finding an electron there. The lighter the shading, the lower the probability. In 2008, Swedish scientists recorded this image of an electron. The shape and shading of this electron cloud should look awfully familiar. Solving the Schrödinger wave equation gives us the shape and energy of the electron cloud for each electron in an atom. The wave equation not only applies to all elements that were known at the time, but also to all elements that have been discovered since. Big idea number 2. Each electron in an atom has an address given by a set of 4 quantum numbers. 3 of the numbers, n, l, and m, result from solving the Schrödinger wave equation. Each energy level n contains 1 or more sublevels L. Each sublevel L contains 1 or more orbitals m. Each orbital m contains 1 or 2 electrons of opposite spin. Spin is given by the s quantum number. Each electron in an atom has a unique set of 4 quantum numbers. Even 2 electrons in the very same orbital must have different values for spin. Let's compare energy levels n in terms of their sublevels L, their orbitals m, and the number of electrons they contain. For energy levels 1 through 4, n equals 1, 2, 3, and 4 respectively. Energy level 1 contains only the s sublevel. Energy level 2 contains the 2s and the 2p sublevels. Energy level 3 contains the 3s, 3p, and 3d sublevels. Energy level 4 contains the 4s, 4p, 4d, and 4f sublevels. Therefore, each energy level n contains n sublevels. How many energy levels would n equals 10 contain? The answer is 10. Let's look at the number of orbitals in each energy level. Since the s sublevel contains only 1 orbital, the first energy level likewise contains only 1 orbital. The 2s sublevel contains 1 orbital and the 2p sublevel contains 3, so the second energy level contains 4 orbitals. The 3s, 3p, and 3d sublevels contain 1, 3, and 5 orbitals respectively. Therefore, the third energy level contains 9 orbitals. The 4s, 4p, 4d, and 4f sublevels contain 1, 3, 5, and 7 orbitals respectively. Therefore, the fourth energy level contains 16 orbitals. Observe the pattern here. 1, 2, 3, and 4 sublevels containing 1, 4, 9, and 16 orbitals. As you can see, there are n squared orbitals in energy level n, Therefore, if energy level 10 contains 10 sublevels, how many orbitals does it contain? The answer is 10 squared, or 100 orbitals. Let's turn to the number of electrons in each energy level. Energy level 1 has only one orbital, so it holds a maximum of 2 electrons. With 4 orbitals, energy level 2 holds a maximum of 8 electrons. With 9 orbitals, energy level 3 holds a maximum of 18 electrons. With 16 orbitals, energy level 4 holds a maximum of 32 electrons. Thus, if you want to know the maximum number of electrons in an energy level, simply square n and multiply the result by 2. Therefore, if energy level 10 contains 100 orbitals, it can hold how many electrons? The answer is 200. You are already familiar with the remaining big ideas. Big idea number 3 is the Pauli exclusion principle. It was Pauli himself who identified the fourth quantum number, spin. As a result, since 2 electrons in the same orbital must have opposite spin, the Pauli exclusion principle can be rephrased as follows. No 2 electrons in the same atom can have the same set of 4 quantum numbers. Big idea number 4 is the Heisenberg uncertainty principle. Big idea number 5 is Hund's rule. Note that all of the electrons in singly occupied orbitals must have the same spin in order to reduce repulsion. Finally, big idea number 6 is the Aufbau principle. Speaking of Aufbau, recall that excited atoms have 1 or more electrons above ground state. By definition, excited atoms violate the Aufbau principle. However, when the electrons emit the photons required to return to ground state, they then return to the arrangement predicted by the Aufbau principle. That's all for this screencast and this unit. Thanks for watching.